47 tests sounds like a test suite. It is, until you look at what those 47 tests actually cover. The tests weren't wrong, they were just asking the same question 47 times. Every test in our Selenium suite was written against one user, a standard Pro account, freshly created, no existing data, one browser, one locale, one set of form inputs the engineer had used when manually verifying the feature 2 sprints ago. The test passed on every CI run, green pipeline, sprint after sprint. While an expired trial user trying to access a feature toggle was hitting a null pointer exception in production. Data-driven testing with TestNG DataProviders is the structural solution to this problem. Genuine equivalence class coverage. The reason most teams don't have it isn't disagreement about value, it's the cost of writing it. 3 to 4 days of copy-paste work. 3 scripts eliminated that cost. 8 days, 47 tests, 200 data-driven scenarios, 1 critical production bug found. Today I'm walking you through every script. Section 1. Architecture Overview. 3 scripts, a clean left-to-right pipeline. Script 1, the Analyser. Script 2, the Generator. Script 3, the Validator, a clean automated flow. The Analyzer parses every test method via Java AST to infer coverage gaps from a taxonomy. It outputs a JSON manifest. The Generator receives that manifest and uses Claude Sonnet to generate complete Java DataProvider methods. The Validator runs a compilation check via Maven and performs duplicate detection, clean code ready for merge. The key design principle: the generator never looks at a test file directly, it only sees the manifest. This prevents generic data generation. Now let's build it. Section 2. Full code and prompt walkthrough. Let's dive into the implementation. The Analyzer is a Python script that parses Java files using javalang. It's AST parsing, not regex, structural correctness. AST parsing handles multi-line annotations and complex types that regex misses. It understands the language grammar. By extracting what the test is asserting on, the system understands the test's intent. That intent drives the coverage gap inference. The taxonomy is product-specific. It maps keywords like payment or role to equivalence classes. This is the heart of the system. The final manifest entry identifies the gaps. Ready for the generator. 1 entry per test. Coverage gaps identified. Script 2, the Generator. Meaningful combinations, not exhaustive ones. It produces methods via Claude Sonnet. The most important constraint: 1 row per equivalence class. This prevents Cartesian products and CI noise. A 12-row cap keeps CI runs fast. Beyond 12, we split into separate named providers, engineering over arbitrary numbers. Realistic test data like new.customer@example.com communicates intent. It makes failure reports readable. Parameter types must match exactly. Passing the type signature into the prompt prevents compilation failures. Script 3, the Validator, catching failures before they hit the suite, compilation and duplicate checks. We compile against the project's dependency tree. It catches type resolution errors that syntax checkers miss. Claude diagnoses errors, turning compilation failed into a 30-second fix. It identifies the exact type mismatch. Duplicate detection uses LLM reasoning to see if rows exercise distinct code paths. It's contextual judgment. Section 3. What the new coverage found. A production bug found 36 hours after merge. The Pro user expired state. The billing service was calling features on a null subscription. 3 months in production, never tested until now. Section 4. The numbers after 8 days. 47 scenarios became 200. Equivalence classes went from 1.2 to 4.1. Manual data provider time went to 0. Coverage increase was 4-fold. Your green CI now means something different. Section 5. The honest caveats: the taxonomy is fragile. Build yours from scratch. Don't copy-paste. Javalang has limits. Complex generics and lambdas need manual review. Know your AST parser's limits. Your test count doesn't measure coverage. Your equivalence class count does. See you in the next one.